Okay, 4D question 13. Now, if you've done question 12, this shouldn't be too difficult because question 12 was like this question but in parts. So what you've got is you've got two different journeys, I guess, and then the question is wanting to find the overall distance from the first point to the last point. Or maybe it's A to C, C to A, whichever's first. It doesn't really matter. We're finding the direct distance between 2 points when there's two separate legs of the journey. Now, what we do this by doing what we've always been doing bearings questions, and that's dividing each leg up into its sort of east, oh actually this one's its north and east directions, so that we can get this dotted line that I've got here, the overall right angle triangle. So this right angle triangle, which is, I've said X and Y, and the hypotenuse is the distance from the one point to the other. But we create this by looking at the other right angle triangles within the question. So this part, so X here is made up of two different parts. We've got the first leg of the journey, which is this right angle triangle, if you can see it, which has 15 degrees here and 9 kilometers as the hypotenuse. If you find this, let's call that X1. X1, let's look at X total. So X1 is this first X part of this right angle triangle. And then if we look at this other distance, there's a 12 here, and they've said this is 75. 75 degrees. Then we have another right angle triangle, and this will be X2. And if we do the X1 plus the X2, we get the overall X of the big right angle triangle. Okay? And hopefully you, if you're getting to this stage of, question 13, you can see how to find these lengths of these other triangles. So again, looking at this one, we have the angle here, the hypotenuse here, and it's the opposite angle. So when we have the opposite and the hypotenuse, we are working with sine, cos, or tan. Hopefully you know which one we're doing. Then you use your use your trig to work out this. And then you'll also use your trig to work out, we'll call this y1, because that's this part here. So this y1 corresponds to here. And in this second triangle, you would use your trig as well to find y2, which is this part here, and y total. So using trig in both of these legs, we can divide up our triangles into their, I guess, east and north parts, if we're thinking about it going this way. And then we can add them together to make this bigger right angle triangle. And then once you have these lengths, then you use your Pythag, and you can say that this this hypotenuse, this direct distance from C to A, is the square root of that squared plus that squared. Okay, so you go through your trig, you do two values in your trig with this triangle. We've got a 15 degrees, we've got a 9 kilometers, and we have another triangle here with a 75 degrees, and well, that's opposite, and the y2 is adjacent, and then that's our hypotenuse. So we have 12 kilometers and 75 degrees. We add the y's together to get this value, and then we get the x's together to get this value, and then use the Pythag to find the hypotenuse. Okay, so there's a bit of working out, but nothing that's too difficult, I hope, conceptually. Just lots of steps.